Will that be fine?
Yes, sir.
Yeah. So we are live now. So just give me a minute. I will start. I will share my screen and we will start the session. Okay. Can you see my screen now?
Yes, sir.
Yeah.
Yes, sir.
Okay. So till week 5, in week 4 we have started for continuous random variable and all, right? And then how to do PDF and CDF and all. Then we in week 5 we have seen some function of continuous random variable and all. Now, so in week 6, okay. So what are the topics? Basically, major topics is first we will going to start from the jointly continuous random variable. Okay, means what? How to? I mean, what are the? I mean, how to see? I mean, what are the PDF or what is the PDF and joint PDF? I mean, suppose I have two random variables, then how to do the things and all. Okay. Same after this. So there are some 2 to 3 main topics: jointly continuous random variable and all. In jointly continuous random variable, we will see the joint density. Okay, density. I mean, and then next we will see the 2D uniform distribution. Okay, and then we'll see how to find the limits for the double integration and all. Then we'll see how to find. Okay, are you able to find the limits for the double integration, or you are facing any difficulty
Able to find, sir.
Yes, sir. Easy, sir.
for the double integration problems? Okay. Then next after that, I think it's marginal density, right?
Yes, sir. Marginal density
After marginal density, we will see independence, how to
and
check
conditional.
independence, and after that we will see conditional density. Okay. So these are the major topics of week 6. Okay. So let me just define, give you the just a brief intro about how to do. I mean, what is the meaning of joint density and all. So if you see for a single continuous random variable, right? If you have x as a continuous random variable, so 2BA is valid PDF, right? So what are the conditions? First of all, tell me. This f of x should be greater or equal to 0, right? And second one is uh, throughout the range, right? This fx dx should be equal to 1, right? And third property was, tell me, this fx is piecewise continuous.
Yes, sir. Piecewise.
Okay. So these were the main property in case of single continuous random variable. Okay, and
So
this
in point two, there was a double integration sign.
yes, I will go to that point. Don't worry, I'm starting with the single one. Okay. So
Okay.
okay, so these were the main three property to being a valid PDF, and this f of x is nothing but a function, right? It's a function of x r to r basically. So in case of joint density, okay, so how to see, I mean, how to define this joint density? Let me write. So joint density in 2 dimensions. 2 dimensions is basically I'm talking about 2 random variables here. So this is nothing but it's a function. I mean, I will say a function fx of y, okay, is said to be a joint density function if what are the properties? Fx of y is greater or equal to 0. Yes or no? As per the you can see for single random variable, and then
Yes.
second one is throughout the
Double
double
integration
of
is
this
equal to
joint,
1.
correct? dx dy should be equal to 1. And what is the third? It should be piecewise continuous for each random variable. Yes or no? So it's a piecewise continuous, right? In each variable. So how to find a probability of an event? So in case of single event, we have seen, right? So to find the probability of an event, suppose I'm saying I'm interested to know what is the probability that this x comma y belongs to A. Okay, for example, then how to find then? So it's nothing but we have to integrate double integration for this A. Okay, just we have to integrate the given joint density function. Yes or no? And this is something we are doing, correct? See, we have done for a single random variable. For example, so this means in case of single random variable, suppose I'm saying what is the probability x less than 1, then what we are doing? We were integrating from lower limit to 1 the single PDF, right? This is something we have done in case of single random variable. Yes or no? So here condition will be given for two random variable. It can be, let's say, x less than 1 to 2y, something like that. It can be anything. But in general, we are defining probability of this thing. We have to we have to do the double integration of the joint PDF, I mean joint density of x. Is this clear? Some rough definition is okay for everyone?
Yes, sir.
Yes, sir.
And what is the support of x and y? How we are defining support?
It
So
is area, sir.
yeah, so
Area.
basically support of it should be, I mean, we have to take x y such that the joints PDF should be greater than 0. Okay, this is something support. Okay, let me give you some example. Okay, let's discuss that. Hopefully that will give you some idea. Suppose I'm saying I have two random variable x and y. Okay, and this random variable have joint density as, okay, let's say joint density. I'm saying I'm taking very simple joint
Sir,
density.
when you explained about the CDF of x less than y, why you are not using the less than equal to, or is it okay to
Where?
say strictly in this the probability of
This
x?
one?
Yeah, yes, yes.
Yes, so fine. See, if I will say x less or equal to 1, right? In case of continuous, I can write probability x less than 1 plus probability x equal to 1. So probability at a singleton by 0 in case of continuous. Okay. So equalities equals and doesn't matter in case of continuous, but it will matter for discrete.
Okay.
Got it?
Okay, and the previous one where you have taken the double integral, why you are not saying minus infinity to a, the below? Yeah, just
See, this okay. This a is not less than, it belongs to a. This a can be anything. Suppose I'm saying x is like between y by half to half, like this something. This a we have generalized, not like a is the upper limit here. Okay, this is basically support for your x and y. Okay, okay. I'm taking the example. I will let you know what is the meaning of that a. Okay, suppose I'm saying fx joint density is given like this. Okay, now here a is what? Okay, I will tell you, and it will take value 0 otherwise. And I ask calculate the probability that this x is like between 0 to 1 and y is like between 0 to 1. Now here a is your this whole thing. Okay, understood? Means you have to integrate this a means I have to integrate x from 0 to 0.1 and y I have to integrate from 0 to 0.1. Is this clear now? Right? Okay, so this is something we can do. So how we have to proceed? First of all, let's try to understand with the graph actually. Okay, so how I will draw the graph? So suppose this is x, this is the y, correct? So if you see the total support 0 to 1, 0 to 1, that means suppose this is 0, this is the 1, right? This is the 1. So that means this is the total support of my x and y, right? Yes or no?
Yes, sir.
And we have to find x should be 0 to 1 and y should be 0 to 1. So suppose this is, for example, suppose this is 0.1, then 0.1. That means I'm interested for this region. Yes or no?
Yes, sir.
So what I have to do to calculate this? I will integrate 0 to 0.1, then 0 to 0.1. See, for here anyhow limits are same. We'll see some difficult problem also, don't worry. So we have to integrate with respect to dx and dy. So what meaning here? So this means we have to differentiate with respect to x first, then this for this is the for y1. Okay, so let's do. So we have to do by part, means by part means let's split. So basically
So can we split the integral sign on both of them,
I,
dx and dy?
yeah, we split means you need you want dy dx, right?
Yes, sir.
Yeah, we can do vice versa. Anyway, we will get the correct same answer. Okay. Okay. So see 0 to 0.1, and what is the value of this joint PDF? It's 1, right? So it will be 1 into dx dy, right? So first of all, we have to integrate this one. So what will the integration of 1? It's x,
X.
right? It will be x
This.
0 to 0.1 and dy. Okay, then it will be 0 to 0.1 and it will be 0.1 minus 0 dy, right? Then what we'll get from here? We'll get 0 to 0.1, 0.1 into dy. So 0.1 I can take outside, so I have to integrate 0 to 0.1, 1 into dy. It will be 0.1 and it will be y, because we have to integrate this thing with respect to y, so I will get y. I think request to then could you? Yeah, so if you do not have doubt, you can mute. There was some background noise. Okay, so it will be 0.1 and we have to put the upper limit. It will be 0.1 minus 0. So basically 0.1 into 0.1. Okay, so which is nothing but 0.1 into 0.1 is nothing but 0.01, right? Okay.
Yes, sir.
So is this clear? Some rough idea how to do this?
Yes, sir.
Okay. Now tell me, suppose, okay, I'm just changing the range and all. Okay, suppose I'm going to do the second part. Suppose I ask what is the probability that your x will be 0.5 to 0.6, okay, then y to 0.1, okay. So if you see, what are the things, okay, let me draw the region, the region where we are interested. Okay, so main region is 0 to 1, right? This is throughout the support of my x and y, yes or no?
Yes, sir.
Correct. And here if you see, y is 0 to 0.1, correct, and x is 0.5 to 0.6. Suppose 0.5 is here and somewhat 0.6 is there. That means our interest of the region is this one, this shaded region, yes or no?
Yes, sir. Same.
Correct. So what we have to do here? Okay, can you calculate this?
Same, sir. 0.0.
Yes, sir.
Yeah. Okay. So okay, if you see what we have to do, we have to. So if I will say 0.5 to 0.6, fxy x comma y, then this is the limit for x. So I have to put dx first, then 0 to 0.1, and then I will put the dy at the second one, right? Is this clear? Some okay. So it will be 0.5 to 0.6, and this value is 1. So we have to integrate 1, and let me separate this term. So here it will be 0 to 0.1, and for 1 dx, that means it will be x 0.5, 0.6 dy, right? So I think we'll get the same answer, right? If I'm not-
Yes, sir. Same
Same
answer. Point
Same
zero.
answer, because we'll get here 0 to 0.1, 0.1 dy, okay? Then we'll get the 0.01, okay? So are you able to relate it now? When
Yes, sir.
okay. Now let's change one, let me change little bit scenario. Okay, suppose I'm asking with the same thing. Okay, means condition is given same thing. The joint density is nothing but 1. Okay, and range of x and support of x and y is 0 to 1, 0 to 1, and 0 otherwise. Okay, now suppose I'm asking what is the probability that x is greater than y. Now tell me, how will you proceed? Yeah, those who have watched the lecture video can tell me. Feel free to say whatever the things you got. How to proceed in this scenario? Yeah, anyone?
Yes, sir.
Yeah, yeah. Go.
This is line y is equal to mx,
Mm-hmm.
and below that area, sir. Below area towards x-axis.
Yes,
Okay.
so we will calculate the area.
Okay, so there is two approach. Okay, so just treat this line as a straight. If suppose in any graph lines are not properly, so this is x, right, and this is my y. So first try to draw the whole support. So support of x and y is this one, right? Correct. 0 to 1, 0 to 1. Yes or no? This is my total support of x and y. Yes or no? Correct.
Yes, sir.
So what is the very first step in such kind of inequality? So step one is, okay, so draw,
Equation y is equal to.
yeah, draw x equal to y. Okay, draw the very first line x equal to y. So I will draw x equal to y. So somewhat x equal to y will be this line. Yes or no?
Yes,
Correct. So if this is the case, so if you see what is the region, what is the our interested region? X
x
greater than
greater
y,
than y.
below part or upper part?
Up- Upper part, sir.
Just think little bit how it will be upper part. Just put any value. Are you getting x greater than y? See, x greater than y means, suppose, okay, you are saying upper part. If I'm taking this value, okay, for example, suppose this is 0.1 and somewhat here it will be, y will be 0.6, right? So here, which one is greater, x and y,
Y.
right? If I will take any value here, that means here it is 0. Let's say 6, and here y will be some 0.2. So x is greater than y in this region, correct?
Yes,
So
yes, lower part.
yeah, you can simply put a value and you can take an idea which region is appropriate, right? For that value, that I mean this condition should satisfy. So that means this this shaded region is my region, and which I have to calculate the probability, right? Yes or no?
That is half, sir.
That is half. Okay, so there are two approach here. First approach is I can apply the area. I mean this.
Area of triangle,
So if you see x
half
greater
adjacent to
than
height.
y, so for this thing, okay, for the shaded region, so what is the area of a triangle? It's half
Half
into,
into base into height.
correct. And what is the base? Base is,
One, sir.
what is the
One.
height?
Height is also one.
Height is, you can
One.
see, it's also one, right? So it's nothing but half, right? Okay, so this is the answer. But let's do the approach two, which is something which we will use most frequently. I mean, anyone is the correct, but try to understand the second approach. Okay, in second approach, what you have to do first, very first step is I draw a line, right, for equality side. Then find the limits of x and y. So what you can do here, okay, first of all, so see, anything is there, anything you can start, I mean anything is, you can draw, suppose if you want limit for x, right, then draw a parallel line to x-axis. Okay, if I will draw a parallel line to x-axis in this region, if you see the red one, correct, draw a parallel line to the x-axis, then what will the limit of x here? Here it is, see, this line, this black line is x equal to y, right? And this one is the y1, right? So can I say limit of x is y to 1? If you draw this line, if anywhere, anyway, I will get the y limit of x is y to 1 or not? Yes or no?
Yes, sir.
Okay.
Yes.
So what I will do, limit of x is I will take y to 1, and since I'm doing the integration and all, then what, okay, for this thing, what is the limit of y? Anyway, limit of y is 0 to 1, right? So you can find for anything, right? So for limit of x is y to 1. So what I will do, I will integrate the region from y to 1, fxy, x comma y. So this is the limit of x, and for dy, I will take total region. Okay, this is the one thing. Another thing is what you can do in reverse order also. Suppose you want to find the limit of y first. Then what I will do, I will do, if I want to find a limit with respect to y, then I will draw a parallel line to y-axis. If you see this blue line, that means I'm getting a parallel line to y-axis. Then what is the limit of y? If you see this is line, this is the x equal to y line, right? Then limit of y will be x to 1, because this is the one. Sorry, not x to 1. It will
Half,
be
sir.
sorry, sir. It will be 0 to x, because
Yes,
at x
X.
axis limit of y will be 0, right? It will be 0 to x, right? Are you getting my point? So second thing will be 0 to x, right? fxy, xy, dy, and 0 to 1 dx. Now, are you able to do the difference? Yes or no? Any doubt?
Yes,
Any
sir.
doubt? Okay. See, if you do with anyone, either with this approach or this approach, you will get the same answer. Okay. We can cross check also. First of all, tell me, did you get the idea how I have calculated the limit of x and then limit of y here? Yes, no?
Yes, sir.
You are getting right. So let's calculate this one, first one. So 0 to 1. So y to 1, and this was the joint one, was the joint density was 1. So it's a dx dy. So it will be basically first we have to integrate with respect to x. So it will be 0 to 1, then x, y to 1, dy, 0 to 1. I will get here 1 minus y dy. Okay. So if you see, I will integrate 0 to 1, 1 into dy minus 0 to 1 y into dy, basically. So I will get here 1. So y 0 to 1 minus here y square by 2, 0 to 1. So just put the limit. So 1 minus 0, then 1 by 2 minus 0. We got 1 minus half. This is within the limit half. So if you see, half is, this is the something we got with the region also, right? Now let's cross verify this one also. So in this case, we have 0 to 1, then 0 to x. So this was for dy, I mean limit for y, and fxy, the joint density. So it will be 0 to 1, 0 to x, 1 into dy dx. Fine. So it will be 0 to 1. Okay. So it will be, this is with respect to y. Okay. So it will be y 0 to x dx, right? So 0 to 1, it will be, then we have to put the limit. So it will be x minus uh, x minus 0, right?
Yes, sir. X minus 0.
X minus 0 dx. Okay. So we'll get x 0 to 1 dx. So this is nothing but x square by 2, 0 to 1. If you put value half minus 0 is nothing but half. So if you say, anyway, we are getting the same answer. Okay. So whatever, I mean, the things comfortable with you. So first of all, just try to find the limit of x or limit of y. Okay. You can take, see, you can take, suppose I'm taking y for 0 to 1, total range. Then you can find the limit of x. To find the limit of x, we can draw a parallel line to x-axis. Okay. Okay, let me take another example. Hopefully, that will give you some idea. Okay. Suppose I'm saying find the probability that x greater than 2y. Then what is the very first, what should be my first step?
We'll draw the
Finding when
equation.
x is equal to 2y.
Right? So this is x, this is the y, and this one is the total support of my x and y, right? Correct. So first of all, I have to draw x equal to 2y, right? Okay. So let's see, for example, x equal to 2y, right? So somewhat x equal to 2y will be like this. Okay. Here just scaling should be proper. Just try to. So x equal to 2y will be line this like this. Yes or no? Okay. So x greater than 2y region will be what? Upper one or lower one?
Lower,
one?
lower one.
Correct. Now, if you see, so now suppose I'm here. I'm going to take x. Let's say I'm proceeding with the. I'm going to take x limit for x 0 to 1 total, right? Then what I have to do, find the limit of y. Yes or no? You can do any one. So okay, first of all, tell me how to find and how will you find the limit of y? Anyone? How will you find the limit of y?
X is equals to 2y.
By putting the value of x,
Okay, how will
so
you do
0
that?
to 2. So 0 to 2
Say
in the
Sir, 0 to 1.
Line
Okay,
parallel to me, sir.
correct. That is something I want to explain. In the previous case, what if you want to find the limit of y, right? First of all, see, if you see the joint density, so we have two things, right? Where it went? Yeah, so 0 to 1, 0 to 1. This is the total support. In that support 0 to 1, 0 to 1, I have to find the probability that x is greater than 2i. So this is this shaded is our interested region. I mean the where we have. I mean the things which you have to calculate. Correct. Now, if I will take the value 0 to 1 for x, but what for y? Or we can do in opposite order also. So limit of to find the limit of y, I will draw a parallel line to y-axis in the region. If you draw a parallel line to y-axis anywhere in the shaded region, so what will the limit of y if you see? So if you see on the x-axis, what is the limit? Limit is on the x-axis, y will be 0, right? Yes or no? So limit of y will be 0 to here. This line is x equal to 2y. So from here y will be x by 2. Yes or no? Are you getting?
Sir, if we take the otherwise, like the previous example, then the limit of y will be
0 to x.
Not okay. Why not 2y to 1? Limit of y.
Okay,
Here,
are you okay? Okay, first of all, tell me, are you going like this or like this?
no, I'm telling the otherwise. The previous example you took, no, y to 1.
No, it's a 0 to y. Sorry.
Okay.
No, y to 1, right?
Yeah,
So if
y
you
to 1.
see, if on the x-axis where we are moving, I mean, which should be the lower, first of all, tell me. Because upper limit is anyhow 1 is, right? Y can be, okay, suppose I'm writing x is here, y to 1, for example, okay? Y to 1, limit of x is, suppose I'm saying it's y to 1. So y can take any value 0 to 1, right? We can't write 0 to y, 1 to y, right? Suppose y is 0.2. So can we write this one? No, right? Are you getting?
Oh, yeah, okay.
Okay. So here, so limit of y will be 0 to x by. Okay, is this clear? Are you getting the idea? Yes, no. See, if you not
Yes.
speak, I will assume
yes,
you
sir,
are getting.
getting,
Okay.
sir.
Okay. Yeah. Thanks. Okay. So then what I have to do? I have to integrate the joint P density. So this is the limit of y. I will put this y as first. So it will be 0 to x by 2, and I will take limit of x is the total one. So if you see, it will be 0 to 1. So this is the 1, right? I mean, joint value of joint density is 1, right? This is the dx part. So it will be 0 to 1, and it will be y. So 0 to x by 2 dx. Okay. So 0 to 1, and this y will be x by 2 minus 0 dx. Now, so I have to integrate x here. So it will be 0 to 1. Sorry, half I
X
can take
square,
outside.
x
This
square
is,
upon 2.
so it will be 1 by 2 x square by 2, 0 to 1, then 1 by 4, 1 minus 0, which is 1 by 4. Okay. Let's do in other way. Suppose I'm interested to first find the limit of x. If you want to find the limit of x, then what do I have to do? I have to draw a parallel line to x-axis, right? Yes or no? Tell me what will the limit of y here? Tell me. Sorry, not limit of y, limit of x.
2y to 1.
2y to 1, right? So basically what you have to do, you have to integrate 2y to 1 join dx, and for 0 to 1 dy, right? If you do this one, right, you will get the same answer as
This is what I was telling exactly. This is
Yeah.
what I was telling, that limit of x will be 2y to 1. See, right now what we are trying, now, this is what I was telling, that limit of x is 2y to 1. So both, I mean, if we stick to one approach, I mean, like, do we need to practice in both the way? They're just asking.
No, anyone is fine. See, if okay, in this, what I am telling the both approach. Sometimes people are taking preferring the finding limit of x first, then limit of y first, something like that. Okay, any one is the either one is a good one. I mean, either one is the good. I mean, the thing is that if you want to find the limit of y, right, first, then what you to do? Just draw parallel line to y-axis. So limit of y will be this. Then for x, just take the whole limit. That's all. In vice versa, if you can find the limit of x first, then take the total limit of y. Okay, fine. So you can go with anyone, not a problem. Is that all right?
Sir, can you just repeat this part alone once, sir? Please, sir.
This thing we need to check. Okay, which one? This 2y to 1.
How to put that limit, sir?
Okay.
In inner limit and out.
Okay, so if I want to find the limit for y, okay, y-axis, then what you have to do? Just draw parallel line to y-axis. Okay.
Okay, sir.
If you draw parallel line to y-axis, just see the where that line is going, where to where. Okay. If you see the red line, it is going from where to where?
From 2y 0.
2y to no. I'm asking about with respect to y.
X to 1.
Just think a little bit. Just see the red line. Where it's going to, from where to where?
From line to x-axis, sir. Red line starts from top. That is x.
Okay. See. This one, right? Then
yes,
it is
sir.
going from x-axis to this line.
Yes, sir.
So what is the limit of y at x-axis?
0.
And this line is x equal to 2y line, right?
2y.
If this is x equal to 2y, then what will the value of y?
X by 2.
That is something we have to take.
Okay.
Got it?
Yes, sir. So that so if we take this straight line, top to bottom line, inner should be dy, outside should be dx. First dy, next dx.
Dx, yes.
I put a horizontal line, first dx, next dy.
Yeah, the same thing you can see we have done in the previous case. Okay. If you see here, if I want to find the limit for y, then if you see the blue line, right? So blue line is going from 0 to x, right? Because this line is x equal to y. So for y will be, for limit of y will be 0 to x. Okay. Then dx will be outside. Okay. Now, if I want to find the limit of x first, if you see this red line, so this is going from y to 1. Okay. So y to 1, if you see this is the y to 1, then dy outside.
Okay, sir. Thank you, sir. Thank you, sir.
Okay. So is this clear? This drawing.
So to that line to parallel to what, x-axis or y-axis? If it is parallel to x-axis, then it gives the limit of
x.
X. If it is parallel to y-axis, then it gives limit of y.
Yeah. Okay. You can see, right, this one. See, this will give you the limit of y itself, right? Okay.
Yeah. Okay.
Any parallel line. Okay. Similarly, we can do for x. Okay. Fine.
Yes.
Okay. So I think after this is the 2D uniform is there, right? 2D uniform distribution. Okay. Okay, so whatever inequality is there, right? So try to find the first thing like I mean, what to say? Just first draw the equal. I mean, suppose x greater than y is there, then draw x equal to y. Then find the appropriate region and then proceed like that. Okay. Fine. Yes, no. All right.
Fine, sir.
Okay. So should we take any, okay, is this clear? Then should we take any doubt from activity or should we proceed? I think it's so opening. Okay, for example, for this thing, for this region, tell me how will you proceed?
First, we create a line of the y is equal to x.
Y equal to
Then
x, right?
we will take, yes,
This
sir.
is the upper
Then the
portion.
upper one will be there.
Yeah. So basically, okay, what will you do? First of all, so here is still, you can see what is the support of x and y. It's 1 to 2, then 0 to 3, right? That means if you draw the region, right? So I will draw the region. I will give you a hint. I'm not going to solve here. Okay. So what is the limit of x? 1 to 2, then 0 to 3. So suppose 0 is here, 1 is here, and 2 is here. Okay. And y is 0 to 3. So suppose this is the 1, this is the 2, this is the 3. Okay. So that means our total support is this one. Yes or no? Because x is 1 to 2. Yes or no? And y is 0 to 3.
Yes.
This is my total region, right? Now, if you see, so first one, this integral, how will you find? Just you to integrate throughout the region, right? Or else what you can do, you can just find this with this help of the region, right? Okay, what is the probability that x less than 1.5 and 1 is less than y less than 1.5? Okay, then tell me how will you proceed? You can solve this without integration also.
In this case, the limit of x and y is given.
Yeah, it's given to you. You can integrate and you can find with either way also. I mean, with the area also. Area. What is it? So, okay, this is the rectangle, right?
Right. So that
What
is
is what
so
is the area?
It is 3. Yeah? Area is 3, right?
Area is 3, right?
Yeah.
Okay, so we have to find when x is 1 to 1.5 and y is 1 to 1.5 means
1 to
x is 1 to 1.5, y is 1 to, suppose 1 to 1.5 means somewhat like this, right?
1 to.
Correct?
Hmm.
So what will be this one now?
0.25.
0.25. Okay. So this, okay, this is the 0.25. This is the area. Okay, let me draw properly. So this red one is the your favorable case, right? Means area of a rectangle is nothing but length into breadth, right? That is 0.5, 0.5, right? Yes or no?
Yes, sir.
This is your favorable case. And what is the total case? Total area is 3.
3.
Are you getting my point? See, probability is what? Probability is nothing but favorable divided by total, right? Yes, no.
Yes,
So
sir.
favorable is what? This red one,
Full
correct?
area.
And for this, what is the
The
area? 0.5 into
complete area.
0.5. What is the total area? 3. So this is nothing but 0.25 divided by 3, which is nothing but 1 by 12. You can solve it. You can solve if you integrate 0 to 1 to 1.5, 1 to 1.5, and I think it was 1 by 3 dx dy, right? So we'll get 1 by 3. Let's take it outside, 1 to 1.5. So it will be x 1 to 1.5 dy. If it will be 1 by 3, 1 to 1.5, it will be 1.5 minus 1 dy. Anyway, it will be 0.5, right? It will be 0.5 by 3, then 1 to
Sir,
1.5, 1 into dy, right? Again, if you solve it, I will get
0.5.
0.5 into 0.5 divided by 3. You can see this is the same. Okay. So you can go with either
sir,
way. Yeah, yes.
is it always will be the dx into dy, or it will be dy into dx?
dy into dx, no problem. You can go either way. Okay, if you're doing dy with dy then dx, then you have to first integrate with respect to y, then with respect to x. Okay,
Answer will be same for both, right?
answer will be same. Yeah, no problem.
Okay,
See,
sir.
you can see we have solved the previous question. Then dy with dx, then dx dy. We got the same answer. Okay.
Yeah. Only to take care to set the limits, sir. No?
Yes, that's the limit and all. Okay. Okay, so I think okay, is this clear, right? You can go with either approach. Okay, fine. Is that
That previous approach,
hmm.
the height is what? Height is uh, 1.5, is it, or 0.5?
0.5? Okay, okay, okay. I think. Oh, one second, one second. I have mistake. I have done one mistake. Uh, Actually, see, this is the 1 to 1.5. This x or y is also 1 to 1.5. Okay, so basically, our suppose
Not
it
below,
will be
sir.
not like this. Oh,
Not below,
thanks for
sir.
the correction. Actually, I have done the mistake here.
1 to 1.5, sir.
It's suppose this is the 1, right? Then it will be like this.
Our part.
Okay, this one. Got it? So if you see, so for this one, right? What is the thing? I mean, what is the area? 0.5 into 0.5, right?
125.
Yes, sir.
Correct. And total is, this total is 3, right? Which is
Mm, mm.
0.25 by 3. Okay. Yeah, thanks for the correction. Actually, I made it. Okay. If it's 0 to 1.5, then this will be bold. Okay. Now, the same thing if you'll do with the integration part, we'll get the correct answer. Okay. So, either way is fine, no problem. Okay. Is that all right so far? Yes,
Yes,
no?
Yes, sir.
Okay. So let's move to the next topic, which is called the 2D uniform distribution. Okay. So how to do that case? That is also interesting part. So in 2D uniform distribution, so that's just something. Okay, let me just give you some rough definition. Let me write that one. Okay. So I mean, we have to basically fix some region. I have to fix some region. What is that region? That region, this region is D in R square, because I'm talking about going with 2D only. Okay. And their total area is modulus D. Okay. If you're not getting the definition, don't worry. I will take some example. Hopefully that will give you some clear ideas. Okay. Then if I will say that the X and Y, joint of X and Y is follows uniform D, I mean for that region, then how to define the joint there? So then they have the joint density as fxy joint density. So I will define the joint density like this: 1 upon modulus of D. Okay, where this xy, mean value of each xy, will belong to that region D. Okay, and it will take value 0 otherwise. Okay, so this is something definition of your 2D uniform case basically. And there is something, we'll get some rectangle and all. Okay, so we'll suppose I'm going to interested in rectangle also. For example, suppose D is the region D is defined as if it this the rectangle.
So far, what we discussed, this is
Hmm.
also 2D, right? So far, what we discussed, this is also 2D.
2D, yeah, but here we'll talk about mostly uniform case.
Okay, within 2D uniform case. Okay.
Uniform case. Your x and y. Initially, it was not the case. I mean, it is not necessary. It will be uniform. But here, I'm going with the uniform case. Okay, something. Okay, then how to find the region and all here? I mean, how to find the probability and all here? Okay, so for any sub-region A. Okay.
Sorry for interrupting, sir.
Hmm.
But the live going on the YouTube, it is restricted.
It is restricted. No, I think it's a live. Is it?
No, sir. I copied the link.
Hmm.
Then I put in the browser. Then it is show the rest video is unavailable. This video is restricted. Please check the Google Workspace Administrator and or the
It's
network
already
administrator.
live. You can you check from the calendar? It's live. Okay. I have pasted the link in calendar.
It's working, sir.
Just check from there. Okay.
No, sir. In my case, it's so video unavailable, sir.
No, sir, it is accessible. Maybe he is trying to access from some other email ID.
Other
That
idea.
No. I just log in with student
Okay,
email ID.
Vivek, one
It's
second.
accessible, sir.
What I'm saying, just check. I have pasted the YouTube link in the calendar. Just take the link from there and try to see. See, if you see already four people are watching in YouTube.
just check. I pasted the link there in the chat.
Okay, sir. I trying more time, sir.
Okay. So rather than seeing on YouTube right now, it's good if you are focusing here. Okay. YouTube is you can watch it later. Okay.
Sir, I joined late, sir. So I see on that YouTube, sir.
Okay, no problem. Just check the link. Okay, so for any sub-region A of out of D, so we know how to do how to find this probability. If suppose X and Y belongs to that region, so we know what is the how to calculate the probability. Probability is nothing but total case. Okay, denominator. I mean, it's nothing but favorable case divided by total case. Means we'll see what is the area of your A and divide by area of by T. So that is something probability we are defining. Let's see some example. Hopefully that will with that example it will give me some idea. Okay, now so suppose uh, let me take a PDF like this. For example, just
Quickly
yes.
asking one doubt. This
Hmm.
CDF and PDF
Hmm.
for continuous and random, continuous and discrete variable.
Hmm.
In a real life, what kind of data analysis they uses this primarily? Like,
Okay, so basically, first of all, you have to see the whether that is okay. Suppose any random variable is given to you. Okay, for example, age is given to you or something like that. Okay, age is given to you or some, and where you to find some you are interested to find some probability. Okay, suppose X is defined as, let's say, age of person. So age is what kind of random variable? It's a
continuous.
continuous, right? Suppose age is the continuous, then suppose I'm asking what is the probability that age of person will lie from let's say 40 to 60. Then how will you find that? Okay, since it's a continuous, then I can simply integrate throughout the region. I will have some approximate probability or not.
Okay.
Fine. Okay,
Hmm.
this is something we can proceed. Okay, so let me take one example for that. Some Cartesian product I'm interested to find.
So in the
Uh,
example what you told, let's say in India, we know people of age from 0 to 100 years, this is their height.
mhm.
And when their age is within 20 to 30, what could be their height?
Yeah, there. Yeah, what is the probability that height will be from here to here?
Okay.
Okay. Okay. So let me take one example. Suppose I'm saying, okay, for that example, for that region. Suppose I'm saying x and y. This is follows uniform distribution. Okay. How? Let's say 0 to 1. Okay, with the product 0 to 1. Okay, so if you see there is definition. If I have written D as a to B, I mean product of a and B, then C to D, that this means X will lie from A to B, then C will lie from C to D, sorry, Y will lie from C to D. Okay, so I'm just writing some region here. Okay, suppose this is the case, and then I'm writing union. Okay, I will let you know what is the meaning of this 1 to 2 and 1 to 2. Okay. Then union of 2 to 3 and 0 to 1. For example. Okay. Suppose I'm writing. Then I'm saying draw. Okay. Suppose question is draw the region. Okay. This region which is given to you. And let's first find joint P density from this. And suppose a question is also find probability that x greater than y. Okay, so first we will find this, and this is something we know how to define 1 upon absolute value of d. Okay, now first of all we have to draw the region. Okay, what is the appropriate region for this? If you see here, so Suppose this is my x and this one is the my y-axis. Okay. So what is this? 0 to 1, 0 to 1. That means first x will lie from 0 to 1, then y will be 0 to 1. Yes or no? That means at the very first thing, I'm talking about this region or not?
Yes.
Correct. Now, second is union of 1 to 2 and 1 to 2. Okay. Suppose this is the 2, this is the 3, and for example, this is the 2, and this one is the 3. Okay. Make sure scaling should be proper, but just 3. So 1 to 2 and 1 to 2. That means y is 1 to 2, x is also 1 to 2. That means union of this thing. Yes or no?
Yes, sir.
Correct. Then union of 2 to 3, this is for x, and into this is for y. So x is 2 to 3 and y is 0 to 1. That means this region. So if you see, y is 0 to 1 and x is 2 to 3. Is this clear?
Yes, sir.
Our the things which are given, these are the shaded region. Yes or no?
Yes, sir.
Correct. So first of all, we have to find the joint density. So we know joint density is what? How we have defined joint density? Fxy, x comma y is nothing but 1 upon modulus of d when x comma y is belongs to d. So first of all, this d is nothing but region. So first of all, we have to find the area of d. Okay. So area of d will be, how will you calculate the area of d? First of all, tell me, what is the area of d here?
3.
3,
How will you calculate 3?
0 to 1, 0
Yeah,
to 1.
for the very first rectangle, it will be 1 into 1, right? Then it's a union, that means plus. For this one, again it will be 1 into 1 plus. For this, it will be 1 into 1. This is nothing. Area of these 3. Yes, no?
Yes, sir.
Okay.
Yes, sir.
What will the joint density here? So we know it's 1 upon modulus of d. That is again, anyway, it will be 1 by 3. Where x comma y belongs to d, and it will take value 0 otherwise. So far so good.
Yes, sir.
Correct. Now what is the next? Next is nothing but we have to calculate the probability that x greater than y, and we have seen to calculate the probability x greater than y, what we have to do? First we will draw a line x equal to y, right?
Yes.
So x equal to y, if you draw, it will be something like this. Make sure it's a straight.
That is 2 by 3.
Okay, just make sure it's a straight line. Okay, just treat that here. I'm not able to draw properly, but just treat as this is x equal to y. Okay. Then we have to find the probability that x greater than y. So we know, if you see any region, probability x y belongs to a, that means modulus of a divided by modulus of d. I means area of a divided by area of d. So we have to find the area of a first. I mean, what is the a here? X is greater than y. That means, okay, what is the which region is our interested region?
Below the
No.
line.
Below one, right?
Yes.
That means this one, right? And this one. Yes or no?
Yes,
Sir.
sir. 2, 3 also, sir.
2, 3 also. Okay.
Yes, sir. Sir, third box.
But for this, it will be 1 totally, right? But for here, if you see, okay, tell me what will the, okay, how will you calculate the this region numerator part? Basically,
That
this is
is
area of A divided by area of D. So area of D, anyway, we know it's a 3, right? In the numerator part, tell me.
2 by 3, sir.
It will be 1 by 2 first of all.
Yes, sir.
Half plus 1.
Okay, why we are taking half?
That is area of triangle, sir.
Area of a
Triangle.
triangle, right?
Triangle.
Half into base into height. Because if you see, I mean, this line should be straight. Here I'm not able to draw properly. Basically, if you see, this is the triangle, right? If you see, this is the triangle, right? This one, correct?
Yes, sir.
Correct. This is the triangle, right? So half into base into height plus for this second again half into base into height and plus
So,
1 for this whole thing, right? Divide by 3. So it
3.
will be 2 by 3. Is this clear?
Yes, sir.
Yes, sir.
Okay, are you getting the idea? Yeah.
Yes, sir.
Okay, fine. Okay, just give me a minute. I will connect my laptop with charging point. Okay, I'll be back in 2 minutes. Hello. Yeah. So uniform part is okay for everyone.
Yes, sir.
Yes, sir.
Okay. So let's do the questions related to some when case is not uniform. I mean, someone asked. I think Bipla or someone asked in the when it's not uniform, right?
One more question, sir. Can
Yeah.
we solve the uniform part by integration also?
Yeah. Why not?
Then how will we?
Okay. So see, first of all, you have calculated the 1/3. This joint is calculated you, right?
Yes,
Yeah.
sir.
Correct. So in this case, what you have to do, if you want to solve, right? So first of all, let's find the region, I mean, support of y. Okay, if you want to support of y, then here it will be limit of y will be 0 to x, right?
Yes.
Then in this case,
1 to x.
1 to x, correct? 1 to x, yeah, here x,
Two
yeah, it's
X.
1. Then here,
0
or
to 1.
so if you see, then you have to integrate 0 to x plus 1 to x. Then I mean here we but just we have to make sure the sorry, limits of x and y. I mean limits of x and y we took properly. Okay.
In case of, sir, 2 to 3, what will be the limit?
In case of 2 to 3, right? This case, I think it should be here. Line is not. Mm, Okay, let me take another example. Hopefully that will give you some right idea. Okay,
Yes.
but anyway, we have to add, means we have to add for this, add for this, add for this. Okay, let me take one more example. Hopefully that will give me some rough idea. Okay, suppose I'm saying xy is uniform D. Okay, I mean the things will be given to us properly so that we can find. Okay, suppose I'm saying D is something 0 to half into 0 to half union of half to 1 into half to 1. Okay. So this means what? Limit of x is 0 to half and limit of y is 0 to half, right? Limit of x is half to 1 and limit of y is half to 1. So far so good? Yes or no? So how to draw the region first of all? So it will be x, it will be y. So 0 to, suppose half is this, 1 is this, half is this, 1 is this. First of all, so this is the first product, right? 0 to half into 0 to half. Then union of half to 1 and half to 1. That means this region. Yes or no? I mean, let me, it should be square, proper square actually. Okay. Okay, so suppose I'm asking, okay, so suppose I'm asking x equal to y, for x greater than y. So this will be the line, right? X equal to y, yes or no?
Yes, sir.
Yes, sir.
And suppose I ask that something, that probability, then now what you have to do, you have to tell me what is the limit of y then. Okay, first of all, you have to find the joint. So joint density will be how much? 1 upon modulus of d. So 1 upon modulus of d. So d is nothing but area of d is what? So it's if you see area of d is, this is 1 by 2 into 1 by 2, correct? That means 1 by 4 plus 1 again 1 by 4. Yes or no? So area of d is half. So here it will be 1 upon 1 by half. That means it will be 2. So joint density we got 2. Now if I ask probability x greater than y in this case, okay. So if you see, first of all, let's find the limit of y. If you want to find the limit of y, then I have to draw parallel line to y axis. Yes or no? Then what is the limit of y axis here in this first box? It's a 0 to x. Then I have to integrate 0 to x. Yes or no? Then 0 to half dx plus next part will be it will be limit of y will be half to x and limit of x will be half to 1 to dy dx. Okay, just solve it and cross check whether it's I mean are getting the same or not. Okay, so let's proceed for the 2D non-uniform when the non-uniform case is there. Okay, if then 2D non-uniform problems. Let's solve some problems related to 2D non-uniform. Okay, so far idea is okay, right? Or any difficulty? Yes, no?
So far, good, sir.
Good. Okay. Yeah, great. Okay, let's do some problems related to non-uniform. Suppose I'm saying I have given the joint density of, I mean, these two random variables have joint density. Okay, let's say fxy x comma y as I'm saying this joint density is nothing but let's say this is x plus y. Okay, then limit of x is suppose 0 to x comma y comma this one. Okay, what do you mean by these things? So this means x is 0 to 1, okay, and y is also 0 to 1. Okay, this is the meaning of this limit. So suppose I'm asking find the probability that x is less than half and y is less than half, and some another probability, let's say probability x plus y less than 1. Okay, now how to proceed in this case? Suppose these are the criteria. So we will start from here. Okay, so first of all, so it's a good to check whether it's a valid density or not. So you can integrate to check the valid density. So what is the property to check the valid density? So we have to integrate throughout the support of x and y, and we'll see whether this integration is coming out to be 1, then it's a valid density. Okay, now how to proceed now? So first of all, so this one is the simple, right? If I will ask probability x less than half, y less than half, that means what? What is the from where to where we have to integrate? First of all, let's draw the whole support of x and y. So x is 0 to 1, right? Y is also 0 to 1. So this is the total support of x and y, correct? Yes or no? And here x is less than half. So this will be 0.5 and this will be the 0.5. So that means now the interested region where we have to calculate this area, right? Yes or no?
Yes, sir.
Okay, so this thing,
And conditions.
yeah. So directly I can apply the integration part here, 0 to half, right? And I have to integrate this with respect to dx or dy, 0 to half. Okay, let's do this. So 0 to half, 0 to half, and this one is nothing but what is that? It's x plus y, right? So dx dy. Okay, so if you are integrating with respect to dx, that means dy we have to consider as a constant, right? So it will be 0 to half. So then 0 to half x dx plus 0 to half y dx. So here y is constant here in this case. Okay, it's a constant value. So 0 to 1 by 2, it will be x square by 2, 0 to half plus y is a constant, then we have to integrate. It will be y 0 to 1, so it will be basically x, right? So 0 to half dy. Okay, now 0 to half, it will be if you see 1 by 2 is there already, and 1 by 2 is square, that means 1 by 4 minus 0 plus y, it will be 1 by 2 minus 0, it's a dy. Okay, can I skip some steps? Will that be all right?
Yes, sir. You can.
Yes, sir.
It will be 1 by 8 plus y by 2 dy. Okay, if you integrate here, right, so 1 by 8 dy, it will be y by 8, right, 0 to half, and then it will be 1 by 2 y square by 2, 0 to half. Am I right? So it will be if you put,
Yes,
so
sir.
it will be 1 by 16 plus 1 by 16, which is nothing but 2 by 16, which is nothing but 1 by 8. So this was the simple. But what about probability x plus y less than 1? How will you proceed for that?
Less than 1
Yeah.
equals to 1.
So question is probability x plus y less than 1. Okay. So this thing we have to calculate probability x plus y less than 1, right? So we have discussed just a few minutes before, if this something some similar case is there, then how to proceed?
First,
Yes,
we will draw the graph, sir. X plus y is equal to 1.
correct. So first we will draw for x plus y equal to 1. So this is x, right? And suppose this is the y. For example, this is the 1 and this is the 1. So anyway, total support was this case, right? Correct, as per the given. So x plus y equal to 1 will be line this one, this line, right?
Yes, sir.
Correct. So this line is nothing but what? X plus y equal to 1. Yes or no?
Yes, sir.
Now tell me, then what is the support which we have to calculate? This shaded one, x plus y less than 1, right?
Yes.
Correct. Now then how to proceed? So if you want to draw a line, suppose I want to find the limit of y. Okay. Then what will be what is the procedure? I have to draw a parallel line to y axis. Yes or no? Anywhere
Yes,
you
sir.
can draw. If you draw a line parallel to y axis, what will be the limit of y? Tell me.
X minus 1. 1
1
minus
by
x.
x, sir.
0,
1 by
to
x.
minus x.
0 to
1 minus x.
1 minus x. Because this line is x plus y equal to 1, then y will be here x 1 by 1, sorry, 1 minus x. And limit of x will be 0 to 1. Okay. Then what we have to do? We have to just integrate the joint density with respect to y, and y we limit it 0 to 1 minus x, and then dx, and then 0 to 1. Is this clear? Okay.
Yes,
I'm
sir.
not going to do the integration. Anyway, integration is same. Just I wanted to highlight here the I mean, these things, how to calculate this one. I mean, sorry, this limit. Is this clear? Fine, right? Okay.
Yes, sir.
Okay. Okay. Let me take one more example. Okay, maybe that will give you some more idea to find the limit and all. Suppose I'm saying x and y have joint density. For example, fx y. Okay, everyone have pen and paper right now.
Yes, sir.
Yes.
Okay, so let's do the problem. Maybe that will give us a clear idea. Okay, or you can just simply tell me. Okay, if you're okay with the integration part, then we'll just find the limit and we'll move ahead. That will be fine. Okay.
Yes, sir. Fine.
So suppose here support is 0 to 1. Total support is 0 to 1 for it. Okay, this is the support of x and y. Suppose I'm just changing the scenario. Suppose I'm interested to find the probability that now you will tell me x less than half, y less than half. Then how will you do? Yeah, tell me how will you proceed for that?
Means support of x is till half. So x-axis you have to take till half.
And y-axis till half, right?
Yes, yes.
That means this one, correct?
Right.
That means I have to integrate 0 to half this 4xy dx and 0 to half this 4xy dy. Yes or no?
Yes, sir.
Correct. If I'm saying probability x plus y less than 1, then so suppose this is the 1, this is the y, this is the 1, this is the 0, then x plus y equal to 1 will be this line. Yes or no?
Yes, sir.
So this
Yes,
is
sir.
the area which we have to find. So tell me limit of y, sorry, limit of x.
0 to 1.
0 to 1.
Okay, first of all, I have to draw parallel line to y, sorry, x-axis,
1 minus y, sir.
correct? If you draw parallel line to x-axis, then this is the lower limit, this is the upper limit. So it will be 1 to 1 minus y,
1 minus y.
right?
1 or 0, 0 to 1 minus y.
Yeah, sorry, 0, 0, yeah. At the y-axis, value of x will be 0. So 0 to 1 minus y, right? So I have to integrate 0 to 1 minus y, this 4xy dx, and for dy, I will take the total limit. Is this fine?
Yes, sir.
What about probability x greater than y?
First we create the x equal to y line.
Okay. Suppose this is the 1, this is the 1, this is the 0. So this is the total support. So first of all, x equal to y, this will be x equal to y line, right? Then if you want to draw, suppose I want to limit of y. Tell me what is the limit of y? I have to draw parallel line to y axis, right? So limit of y will be
0 to y.
0 to y.
Mm,
0 to
No.
x.
0 to x.
0 to
Yes, sir.
x, because
X.
this is the y equal to x.
X.
4xy dx dy. Is this fine so far?
Yes, sir.
Okay. So, okay, let me give you some another idea for the similar case. Okay.
Sir,
Yes.
this case was for probability x is greater than y, no?
Huh? Yeah, go ahead. What is
And
the other?
had it been x less than y, sir?
X?
Less than y. Then
Okay.
for above triangle, what should be the limits?
Okay, now you will tell me if this is the case, x less than y, right?
Mhm.
Okay, tell me what I told you. So this will be your interest of region, right?
Yes, yes.
Okay, in this region, if you see, if I want to draw, if I want a limit of x, for example, what will the limit of x? Okay, first of all, what I have to do to find the limit of x? I have to draw parallel line to x-axis. Yes or no?
Yes, sir.
Then what will the limit of x here?
0 to y.
0 to
Y.
So you have to do 0 to y, 4xy dx dy 0 to 1. If you want to find the limit of y, then I have to draw parallel line to x-axis. Sorry, y-axis. If you draw parallel
Yes, sir.
line to y-axis, then this is the line, right? Tell me what will the limit?
X to 1.
X to 1.
1.
Because this is the 1. Got it?
Yes.
Yeah. Is this fine, right? Now it's okay or any difficulty? Yes, no, all right.
So the last one, can you explain again, sir? P of x less than y.
Okay, for x less than y, this is the support one, right? The above triangle, right? Anyway, you can you can apply the area. I mean, area of triangle also. That doesn't matter. So if you if you see the I want to find the limit of x, then I have to draw parallel line to x-axis, right? Correct.
Yes.
If you draw parallel line to x-axis, that is what from where to where it's going on 0 to y, right? Then you can simply integrate 0 to y, and I can take a limit of y 0 to 1, and I will integrate. Okay.
Yes, I got it.
Okay. Yeah. So let's. I think after this, the marginal density is there, right? If I'm not wrong.
Hello, sir.
Yes.
Sir, marginal.
Sir, for x less than y, we can also do 1 minus probability of x greater than y.
Yeah, you can do, no problem.
Okay.
Okay. Either you can also apply the area of triangle also, right? Anyway, you will get the same answer. Okay. So next topic is marginal density. So marginal density we have seen in case of, okay, in case of discrete, if you can remember, in case of discrete, what we have done, if I have to calculate the marginal density for x, then what I had to do? I had to do the summation throughout the range of y, the joint PMF of x and y, yes or no? Or if I want to calculate the joint, marginal density, marginal PMF of y, then I had to add throughout the range of x, the joint PMF, right? This is something we had done in case of discrete. Yes or no?
Yes, sir.
So in case of continuous, we know in case of continuous, what we have to do, rather than do the summation, I have to do the integration.
Integrate.
Basically,
Yes, sir.
this integration is nothing but called continuous summation, actually. So suppose, suppose marginal density is something. Suppose I'm saying, let's just give me some definition. So suppose x and y have joint density. Okay. So joint density. Suppose this is given as fxy of x comma y. Then very first thing. So x has the marginal density. So in case of marginal density, what I will do? I will integrate the thing. Okay. I will integrate to calculate the marginal density of, I will integrate the joint P density with respect to y. Okay. So limit of y. Okay. If I want to calculate the marginal of y, then y has the marginal density. Then to calculate the marginal density of y, what I will do? I will integrate the joint density with respect to x. Is this clear? Some rough idea?
Yes.
Yes, sir.
Okay.
Sir, can
Now,
we say that integrate over everything we don't want?
no, it doesn't mean we don't want. You have to check whether it's a joint density, valid density is not, the joint density is valid or not. Then you need to do double integration. But for the calculate the marginal one, right? If you want to marginal density of x, then you have to integrate only with respect to y. If you want to marginal density of y, then we have to integrate with respect to x. Okay.
As we don't require y, so we integrate over y. Okay, sir. Got it.
Yeah, that's right. That is the meaning, right? If you see the discrete case, I need the x, right? Then what I have done, I have added all the joint PMF throughout the range of x, sorry, y, right? So here, instead of adding, I will do the integration part. Okay. Okay, let's start with that part, x comma y. Let me take that uniform example also. Suppose I'm saying x, y is follows uniform D. Okay. And what is this? Where I'm saying where this my D has been defined as 0 to half into 0 to half union of half to 1 product of half to 1. Now, if you draw this region, okay, let me get. So this is x, this is the y. So this is suppose 0, half, 1. Suppose half is here, 1 is here. Okay. So first region is this 0 to half into 0 to half, right? And then half to 1, half to 1, this one, right? Yes or no? I mean, it should be proper square, okay, for example. Okay, so first of all, what is the area of D? So area of D will be what? So area of D is this thing plus this thing. So what is the area for this? Half into half, right? That is nothing but 1 by 4. And for this, again 1 by 4, right? This is nothing but total half, right? So if you see what is the joint density, is 1 upon modulus of D, that is nothing but 2, correct? So this is joint density. So what I'm trying to explain here, suppose I ask what is the marginal density of X. Now, so what I have to do to calculate the marginal density of X? I have to integrate the joint density with respect to Y, right? Now to integrate with respect to y, what I have to do? I have to find the limit of y. Yes or no? To find the limit of y, what I have to do? I have to draw a parallel line with respect parallel to y-axis. Yes or no?
Yes, sir.
Correct. So if you see in the both cases, what is the I mean thing is there. So okay. So if you see in this case, in this part, in the very first part, when there are two things where x is 0 to half, right? For the first square. So what I have to do? I have to integrate this joint 2 to dy. And what is the limit of y now here? Tell me.
Half.
Only half.
0 to half.
0 to half,
0
right?
to half.
Correct.
So
So
y.
it will be 2y 0 to half, and we'll get 2, 1 by 2 minus 0, nothing but 2 by 2, which is nothing but 1, right? And this is the when x is 0 to half. When x is half to 1, then when x is half to 1, we have to basically we have to see for both cases. Because sometimes value of f of x, see, that's why we have seen that the piecewise continuous. I mean, it's possible for this square value of x will be some other thing, for this square value of x will be some other thing, something like that. It's possible, but here it's not. Let's see. Okay, so half to 1. So if you see here, what is the limit of y again? It's again half to 1, right? So we'll do again, we'll get 2, 1 minus half, which is nothing but 1 again, right? So that means what here, what we have derived here. So f of x will be, it will take value 1 when to when 0 to x, sorry, x will be 0 to 1 and 0 otherwise, right? In both cases, it's taking value 1, right? Yes or no? Yes, no, any doubt?
Yes, sir.
Okay. So see, okay, are you getting why I have done in the some, I have split the cases of, I mean, ranges or support of x? Any idea why I have done like this?
For different curves, sir.
for different color. Okay, because okay, let me take another example. Hopefully that will give you idea why we have to do like this. Okay, in case of if uniform is there given to you. Okay, let me take another example. Suppose I'm saying, okay, suppose I'm saying x y is defined as uniform D. Okay, and where my D is nothing but, let's say, 0 to 1 and 1 to 2, union of 1 to 2 and 0 to 1, then union of 2 to 3 into 0 to 2. Okay. Now, so this is something we have to see a little bit uh, carefully. Just treat this line as a properly. First is 0 to 1. Suppose this is 0, 1. Suppose this is 2 somewhere here, then 3 somewhere here. So this is 1 come out here, 2 is here, 3 is here. First is 0 to 1 and 1 to 2. That means x is 0 to 1, right? And y is 1 to 2. That means this region, right? Yes or no? This 0 to 1 and 1 to 2, correct? Union
Yes,
of 1 to 2. So x is 1 to 2, y is 0 to 1. That means this one, okay? Then x is 2 to 3, y is 0 to 2. So that means x is 2 to 3, y is 0 to 2 to 2. That means this one, correct? So basically these are the region where we have to focus. Yes or no? So this is D, right?
yes, sir.
Okay. So what will the area of D? Tell me. So area of D, so we have to add the area. What is the area for this one? Tell me, area is how much?
1 into
2, 2, 2.
2.
Oh no, sorry, one. It is 1, 1, 1.
1, right? And for this?
Again 1.
For this?
So this is 2.
1 into 2, right? That is 2. So basically 1 plus 1 plus 2, that is 4, right? So what is the joint density we will get from here? 1 upon modulus of D, that is nothing but 1 by 4, right?
Yes.
Yes, sir.
Correct? And 0 otherwise. Now, so yeah. So main thing is, suppose I ask what is the marginal density of X? So to calculate the marginal density of X, what we have to do, if you see the little bit carefully here, if you focus, so what we have to do, how will you find the marginal density of X? First of all, we have to find the limit of Y, right? Because we have to integrate with respect to Y. So basically, if you see, when X is 0 to 1, 0 to 1, correct? Then what is the limit of Y here?
1 to 2.
1 to 2, right? That means I have to integrate 1 to 2, the joint density, which is 1 by 4 dy, yes or no?
Yes, sir.
Correct?
Yes, sir.
When x is 1 to 2, then what is the limit of y here?
0 to 1.
0 to 1.
Then I have to integrate 0 to 1, 1 by 4 dy. Yes, no?
Yes, sir.
If x is this in this range 2 to 3, then what is the limit of y here?
0
0
to
to
2.
0 to
2.
I have to integrate 0 to 2 1 by 4 dy. Now integration you can do, right?
Yes.
Okay,
Yes,
can
sir.
you tell me, by solving this, can you tell me what will be the value? You can take some 4 to 5 minutes. What the exact PDF will get for X, marginal density of X?
So first one we will get 1 by 4 only. If,
Okay.
So 1 by 4 for 0 to 2 and 1 by 2 for 2 to 3.
Okay. For 0 to 1, it's
second one also 1 by 4.
1 by 4, yes.
that means you are saying this fxy, sorry, fx of x.
Last one is half.
Okay, this means fx of x, you are saying 1 by 4, right?
Yes.
0 to 1, right? Then 1 by 4, 1 to 2, right?
Right.
And then
Yes.
last one is half.
half from 2 to 3, right?
Yes,
Yes,
sir.
So that means I can say fx of x is taking 1 by 4 from 0 to half, sorry, 0 to 2.
0 to 2. Yes.
Then I will say half 2 to 3, and it will take value 0 otherwise. Yes or no?
Yes.
Is this clear? Some idea is okay? Density, marginal density you can calculate, right?
Yes, sir.
Okay, fine. Yeah, great. So let's see the next concept, which is called independence. Okay. So marginal is important because to know the independence. Okay. So if suppose you will tell me, suppose I have two events. Let's talk about first in terms of events. I have two events A and B. Okay. Then when I will say these two events are independent.
When their product of marginal is equal to joint.
Okay.
Means the happening of or not happening of one
Correct.
event does not affect the probability of others.
Basically, independence means if I say probability of A whether B is happening or probability of A whether B is not happening is equal to probability of A. In reverse order also means probability of B given that A, probability of B given that A is not happening is equal to probability of that. Then I will say A and B are independent. Actually, the thing which we are saying joint equal to product of marginal, we are getting from where? So actually, we are saying probability of A given B is equal to probability of A. Okay. Now, what is the conditional probability is defined? How? So A intersection B divided by probability of B, right? Then equal to probability of A. Yes or no? If you see from here, so probability of A intersection B is nothing but probability of A into probability of B. Can I say? So this is something we have to check in case of independence. The same concept will apply here. If we have two random variables, okay, then how we'll check the independence? That means I will say X and Y are independent. Okay. If the joint density of X and Y is equal to their
Marginal.
okay, if this is the case, or I will say if x given y, okay, at equal to y at x, if this is equal to f x of x, then I will say independence. Okay, because happening of y doesn't affect on x, right? Vice versa. Basically any either way is fine. Okay, is this clear? Yes, no, idea is okay, right? Let me take one example for independence. Suppose I'm saying x and y, okay, is from uniform D, okay, and where D is nothing but let's say 0 to 1 and 0 to 1 for our simplicity. Let's take for this one. So what is the total support of x and y? So suppose this is the 1, this is the 1, this
0
is
to
0.
1.
So this is the total support, right? Okay, this is total. So then what is the area of D?
1, sir.
1, only 1, right? So how will you define
Yes,
the
sir, 1.
joint density? Joint density is nothing but 1 upon modulus of D, and which is nothing but 1 again, right? Yes or no? And you take
Yes, sir.
value 0 otherwise. Okay. So to calculate, okay, so this is the joint. Suppose this is the question and I ask whether check whether x and y are independent or not. Then you have calculated the joint density. Okay. Now I need to calculate the marginal. Yes or no? So to calculate the marginal fx of x, what I have to do? I have to integrate the joint density throughout with respect to y, right? So what is the limit of y? 0 to 1, right?
0 to 1.
It's nothing but 0 to 1, 1 into dy. Again, it's a y, 0 to 1, nothing but 1 minus 0, which is again 1, right? Same, I need to calculate the marginal of y. So for to calculate marginal of what I have to do, I have to integrate throughout the
0 to 1.
limit of
fx
x.
1 into
Again, it would
dx.
be x 0 to 1, 1 minus 0 is nothing but. So you can see here, joint density fxy is equal to 1, which is same as product of their marginals or not.
Yes,
Again, nothing 1
same.
into 1. So I will say this will imply x and y are independent.
Independent.
Is this clear? Yes, no?
Yes, sir, clears. Yes, sir, clears.
Okay. Let me take another example. Okay. Suppose I'm saying x comma y, okay, is from uniform D, okay, where and D is defined as nothing but, let's say, 0 to 1 into 0 to 1 union of 1 to 2 into 1 to 2. Now tell me, okay, whether x and y are independent or not. So, okay, you will tell me, I will just solve it here. Tell me how I should proceed. To calculate x and y are independent or not, first of all, I need to find the joint density. To find the joint density, I need to draw this region. So 0 to, this is 1, suppose this is 2. So somewhat 1 is here, 2 is here. Okay. So first region is this one, 0 to 1 into 0 to 1. Yes or no? Right?
Yes, sir.
Then 1 to 2, 1 to 2. That means this one. Just draw the square properly. Okay. Okay. So these are the region, right? Now tell me, I have to find the area of D. To calculate the area of D, so what is the area of this region? 1.
1.
And what is the area of here?
Again 1.
So area of D is 1 plus 1, which is nothing but 2. So joint density is nothing but, tell me what it will be, 1 upon modulus of D, which is nothing 1 by 2, right?
Yes.
0. Now tell me, now you will tell me, I will solve it, or just take some 4 to 5 minutes and tell me whether x and y are independent or not. To calculate this, what you have to do? Okay, tell me whether you want to do this or I should do this. Either way is fine. You want to try?
Sir.
Okay, yeah, great. Yeah, just take some 5 minutes and tell me. Let me give you a hint. If you want to calculate the speed, whether it's independent or not, first compute the marginal density of x, then marginal density of y, and then let me.
It's not independent.
It is half is equal to 1 by 4 it is giving, no?
Yes, not independent.
Okay, so someone is saying it's not independent. Why?
Independent, sir.
Yes.
fx into fxy, we are getting 1.
Means marginal product of marginal density, you are
Product
getting
of
1.
marginal is 1.
Okay. How?
It
Okay,
is
first
one.
of all,
It
tell
is
me
one
what
by 4, no?
It's
Okay.
1 by 4, sir.
What is the marginal of fx? First of all, to tell me what is the margin of x. So first of all, this thing we have to see when x is 0 to 1, right? In case of 0 to 1, I have to integrate joint from 0 to 1, right? Yes or no? So
Yes, sir.
it's a half dy. So it will be half. It will be half anyway, right? Correct. Again, if you see 1 to 2, correct, in this support when x is 1 to 2, right, then limit of y is again 1 to 2 half dy. Again I am getting the half. Okay, that means I will
Yes.
say the marginal density of x is nothing but half when 0 to 2, right? Am I right? And think, is this correct way, right? Yes, no, are you good? Okay, so for y, what we have to do, we have to okay, we have to draw the parallel strip with respect to x, right? So limit of x anyway it will be 0 to 1, and in this case it will be 1 to 2, right? So I have to integrate to 1 by 2 dx 0 to 1, right? When y is 0 to 1, and I have to integrate when y is 1 to 2, again 1 to 2 half dx. Anyway it will be half, it will be half. So I will say that y is nothing but half for the support when y is 0 to 2. So if you see joint density is how much? Half, right? This is, and product of marginal is, it is 1 by 2 into 1 by 2, which is nothing but 1 by 4. So I will say here fx joint density is not equal to product of marginals. That means x and y, they are not independent. Is this clear?
Yes, sir.
One other approach is that you can tell me by saying the figure itself without calculation. You can simply tell me how you can find the whether it's independent or not. Can you think?
Yes, a range of y is 1 to 2.
Hmm. Okay, let me give you one idea. Okay, when both two things are related or dependent, means if I'm going, I mean those two are affected to each other, right? If I'm going to make changes in one, that will reflect me change in another one or not. Then I will say both are dependent, right? Yes or no?
Yes, sir.
Yes, sir.
See,
If we change
depend.
one,
If you are going
area
to
will
make a
change,
change
sir.
in one, that should reflect the change in another, right? That then I will say those two are related, those two are dependent to each other. Yes or no? So if you see in the x-axis, initially it's 0 to 1. If you will go 1 to 2, right? Then there is a change in y also, right? Initially it's 0 to 1, then y is also changing 1 to 2. Yes or no? That way it's a dependent. And it is something you can think in case of when this uniform region is there. It's not true for always. You can just think like this. Okay. Whenever in the previous case, if you see, this is the 0 to 1, 0 to 1 support, right? If you see in x axis, in y axis, if you make any changes in x, y will not affect, right? It's the same throughout the region of x. Yes or no? Yes, no idea, anything? Are you getting?
Yes, sir.
Okay. Suppose, for example, suppose I'm saying uniform support is given to you like this. Suppose this is the x, this is the y. Okay. Just suppose y 0 to 1 and 2. So suppose I'm saying Cartesian product is given to you like this. I mean, suppose I'm saying D is defined as 0 to 1 and 0 to 1 union of 1 to 2 and 0 to 1. For example, this is the case. Then you will be having this case, right? I mean, this first box and the second box. Yes or no?
Yes,
These
sir.
two, right? Now, by saying this, can you tell me whether this will be dependent or independent?
Independent, sir.
Independent. Because if you see x is 0 to 1, if you change in x-axis and if you go 1 to 2, still y is same, right? Y is same throughout the case, right? There is not any effect on y-axis, right? I will say x and y are independent. So you can check with the integration also, but just keep in mind this is true only for uniform case, not for non-uniform case. Okay, it is true for uniform case only. Okay, fine. All right. Yes, no. Uh, okay. So should we move to the next topic?
Yes, sir.
Okay. So next is, I think this is the last one, conditional density. Okay. So we know how to define conditional probability of two events. So probability A given B is nothing but probability of A intersection B divided by probability of C. Correct? This is something we are defining the uh, conditional density. Okay. So in case of continuous and all, so I will say for a I mean for a value A, and which A is such that, suppose I'm saying fx of A is suppose greater than 0, then I will say conditional density of y given x equal to A, okay, at y, this will be joint of A comma y divided by fx of A. Okay, are you getting? If you are not getting, we can simply define in general f y given x equal to x at y. This is nothing but fx y x comma y divided by fx of x. Okay, we can do it reverse order also. If f x given y equal to y for a value x, it will be same as joint density of x comma y divided by f y. Is this clear? Actually it is very exact similar as this quantity. Okay, joint divided by marginal. So joint divided by the given case marginal. So joint divided by the given case. Okay. So this definition is okay for you? Yes, no? Is that all right? Anything?
Yes, sir. Okay.
Yes, sir. Yes, sir.
Yeah. Okay. So you can acknowledge. Otherwise, I will assume you are getting the things. Okay. So it's good. Just you can tell me whether you are getting the same any concept or not. Anything. Okay. Let me take one example for that same. Okay. So let's say I'm saying the joint density is given to us. Okay. For example, let's proceed with joint density itself. Okay. Then we'll do, yeah, let's say this joint density is given to us. Suppose this is something 6x square y. You can take 0 to 1, 0 to 0, otherwise. Okay. Suppose I'm saying we need to find the probability that to y is greater than, let's say, 0.5, given that x equal to 0.5. Okay. So what do we mean by here? What we have to calculate. So this conditional will be equal to, I mean, this y greater than 0.5 and x equal to 0.5, right? Divide by probability x equal to 0.5, right? This is something we have to calculate, right here. Or I can write here fx at 0.5. Yes or no? Right? So if you see the numerator part, that means in the numerator part means I have to find the joint probability. Basically, I have to integrate 0.5 to y. Okay. So this is, if you see x is fixed here. I mean, fixed means one value is given to us for x, which is here you can say it's for a. Here is 0.5 is given to us. So we have to integrate this joint density only for y. Yes or no? And limit of y, you can say it's greater than 0.5, then you have to integrate 0.5 to 1, which 1 is the upper limit. And in the denominator, if you see denominator is what? How will you find this is something marginal density of x, right? So to calculate the marginal density, what I have to do? Yeah, tell me.
Integration over y fxy of x comma y dy from
Right?
0
0 to 1.
1
0 to 1, right? Because see, to calculate the marginal density, we have to integrate throughout the range support of y. Okay.
Yes, yes.
Fine. So let's calculate the numerator part first. So numerator part, did you get how I have written like this? Yes or no?
Yes, sir.
Okay. So let's calculate the numerator part. So 0.5 to 1 fxy 0.5 comma y dy. So if you see 0.5 to 1, what is the fxy is given to us? 6x square y. So it is nothing but 6x square is 0.5 y square. Okay. Y dy. Okay. So it will be 0.5 square means I can write 3y by 2. This 6 into 0.5 square. Okay. So I will write 3y by 2 0.521 dy. Okay, so it will be 3 by 2 will be outside, so it will be 0.521 y dy 3 by 2, it will be y square by 2 0.521, so it will be 3 by 4, 1 minus 0.5, that means half, so it will be 3 by 8, right? No, not 3 by 8, so it's
Get 6 also.
yeah, 6 we have missing. Yeah, 6 we have missed. Yeah, sorry. No. One second, one second.
1 minus 0.25.
I think calculation is correct.
No, limit. Y
In the
square.
last
1
line,
minus.
0.25, I think. 1 minus 0.25.
Yes.
Y square is there.
1 minus
In the last line, sir, 3
0.25.
by 4 into 1 minus 0.25.
Oh, yeah, correct. Yeah, that's why I'm thinking. So it will be 3 by 4, 1 minus, I think it's a 1 by 4, right? Basically. So 3 by 4, it's again 3 by 4, which is 3 by 16. Okay. Sorry, 9 by 16. Okay. Now, so in the denominator part, yeah, thanks for the correction. So it's we have to do, we have to calculate basically fx of x, which is nothing but it's a 0 to 1 fxy x comma y dy, right? So we have to do 0 to 1 6x square y dy. So 6x square is nothing but constant here, right? So we have to integrate 0 to 1 y dy. So it will be 6x square, it will be y square by 2, 0 to 1, it will be 3x square, then 1 minus 0, which is nothing but 3x square actually. So if you see 3x square is fx of x. Okay. So at a point for any x, let's say it's a 0.5, then it will be 3 into 0.5 square, right? So I think it will be again 3 by 4, right? Yes or no? So what will the conditional probability here? Conditional probability is nothing but this part 9 by 16, this joint density divided by 3 by 4. So it will be 9 by 16 into 4 by 3, which is nothing but basically you will get 3 by 4. Is this clear? Basically, we have to focus on conditional, joint divided by marginal. Is that all right?
Sir, why did we take the value of x 0.5?
It was given, actually the probability which you have to calculate, this is the case we have to calculate.
Okay, sir.
Rather than calculating in general, we have to do this. Okay?
Understood.
Okay. Is this clear to all of you? Right? Yes, no? Is this fine?
Yes, sir.
Okay. Any doubt?
No, sir.
Okay, so I'm just giving you one thing. So what you can do, one question. Is there any session from 8 or no? Is there any session from 8 p.m.? Yes, no, you.
No, sir. No, sir.
I don't know what is the thing if you are not. Okay, so tell me. Okay, so this is the suppose I'm saying. This is the case. I'm asking find conditional of f y given x equal to x y and f x given y equal to y x. Okay. So tell me whether you want to do it now or do it later, or should I do by seeing the question? If you want to try, we can wait. This will take some long process. Means first of all, you have to find the D, area of D. It will be 1 upon, then joint density will be 1 upon modulus of D. Then you have to calculate the marginal. Okay, you want to try? Okay, let me give you that part. Let me give you the joint density. Maybe after that you can calculate it. You will get the idea. Okay, so you're saying I'm saying it's a uniform D, but my D is defined as 3x greater than y. Okay, something like that. Suppose let me draw the region properly. Suppose this is x, this is the y. Okay, suppose this is 0, this is 1, somewhat 1 is here. Okay, so y is greater than 0, it can take any value actually, but actually 0 to 1. So so here you can see, so what you have to I have to draw y equal to 3x, right?
Yes.
Right? So y equal to 3x means somewhat it will be like this. Yes or no? This will be y equal to 3x. Just treat y is equal to 3. I mean that slope and all we have to adjust properly, but here main focus is to find the limits. Okay. Now, so what? Okay, y is less than 3x, right? So which region we have to see? Lower one or upper one? You can put any value and you can verify which region is appropriate. Y is less than 3x or 3x is greater than
Lower one, sir.
lower one, right? Correct. So lower one, this is the our region which we have to see. Now, so this is the D here, right? First of all, I have to find the area of D. So what is the area of D here? Tell me.
Half, sir.
Half? Only half.
Yes.
3 by
Base into height. Base into height.
So what is the base?
1.
What is the height?
1.
Height
3.
is 1. Height is 1.
3.
Just think, just think. This is not a 1 here.
3,
Why?
sir.
See, this point is what? This point is 1 comma 3, right?
Yes, sir. 3, sir.
So it will be 3, right? It's a 3 by 2. Correct? Is this clear? Okay. See, here y is, if you see y is greater than 0, it's not like y is less than 1, right? So, what is the joint density here? Joint density will be 1 upon modulus of D. So, 1 upon modulus of D, this is nothing but 2 by 3. It will take 0 otherwise or in D. Correct? Now, joint density is clear, right? Now, just calculate this one. Okay. To calculate this, okay, first of all, see what are the things I need to calculate this y given x equal to x. So, f, let me write here, fx y given x to x, I need joint density, right? It's a y given x equal to 1 second. So it's f of y given x equal to x of y. So it's a joint density, right? Divided by marginal of x, right? So first of all, I have to calculate the marginal of x, right? So what is the marginal of x? To calculate the marginal of x, I have to integrate the joint density throughout the support of y. Tell me, to calculate the y, to know the limit of y, what I have to do? I have to draw a parallel line to y axis, right?
Y-axis. Yes.
So what is the limit of y axis now here? 0 to this line is 3x, right? So I have to integrate this thing 0 to 3x. Is this clear? Are you getting? So 0 to 3x 2 by 3 dy, it will be 2 by 3 y 0 to 3x. Basically, it will be 2 by 3 into 3x, which is nothing but 2x, right? So marginal density of x is 2x here. Is this clear? Right? For the support of x. Yes or no?
Yes, sir.
And what is the marginal density of y? To calculate the marginal density of what I have to? I have to draw parallel line to y-axis. To calculate the marginal density of y, I have to integrate the joint density with respect to s. That means I have to calculate the limit of x. To calculate the limit of x, what I have to do? I have to draw parallel line to x-axis. Then what is the limit of x-axis from here? Tell me.
So y by 3 to 1.
Yes, because this is y equal to 3x line. So here x value of x will be y by 3 to 1. So I have to integrate it's y by 3 to 1. Okay. So it will be y by 3 to 1, 2 by 3 dx. Okay. So 2 by 3, anyway, it will be x, y by 3 to 1. It will be 2 by 3 and it will be 1 minus y by 3. Okay. So if you see, now, what is the, I have to calculate the conditional probability y given x equal to x 2x, right? That means joint, right? So joint density divided by marginal of x. So what is the joint? Joint is 2 by 3. Marginal of x is, we got 2x, right? So what is this? This is nothing but 2 by 6x, right? That means 1 by 3x for the support of x, right? 0 to 1. Now tell me, can you tell me what kind of distribution is this one? And what is the support of air? This conditional probability. What is the support first of all for this? Miss, can you tell me the distribution of y given x equal to x? By saying this 1 by 3x? Anyone? See, y given x equal to x, what is the distribution? I got 1 by 3x. Yes, no, if you're not getting idea, you can simply say, tell me no. Don't have any problem.
Not getting, sir.
Okay, can I say it's a uniform from 0 to 3x or not? Just think.
Yes, sir.
Yes or no?
Yes, sir.
Okay. What about x given y equal to y here? Just tell me. So joint density is 2 by 3, right? And marginal was for y is 2 by 3 into 1 minus y by 3. Okay. So 2 by 3 will get cancelled. I got 1 divided by 1 minus y by 3. Now what kind of distribution is this?
Uniform, sir.
Okay, uniform. What is the limit?
1 to y3. 1 by y by 3.
Y by 3 to 1, right?
Yes, sir.
Yeah, this is something conditional probability is there, right? If you want to calculate the conditional, I need the marginal density and I need the, I have to divide actually joint divided by marginal density. So first of all, if it's something uniform is given to you, right? Then we have to calculate area of D and I have to do 1 upon modulus of D. Then I will get the joint density. Then similarly we can calculate the margin. In chat box, Manish is saying y is 1 to 1.5. He's saying diagram is wrong. Manish, which diagram are you talking about? Manish, are you there?
No, sir, it's for previous sir.
Okay, so it's right. It's correct now, right?
Yes, yes, sir.
Yeah. Okay, fine. Okay. Okay. Is there anything else? I think we have covered the content, right? Did you get the idea? Did you get the how to find the limits, how to find the 2D integration and all? Will you able to do it? Conditional probability and all? Yes, no?
Yes, sir.
Okay, yeah. Okay, anything else? I think most of you have not covered the lecture video itself right now, till now, right? Okay. Okay, so if this is the case, so try to cover the content because Wednesday is the due date for week 5 and week 6. Okay, together. So try to do the things on time. Okay, yeah. Okay, then if it's there's nothing else, then we can wind up.
Sir, one more question.
Yes, yeah.
Sir, somehow actually I get a chance to cover up the week 5 session. So is there any chance to get these videos, maybe if you are recorded or something?
Sorry, this today's recorded video?
Yeah, not today. Today is fine anyway. I was there. So for week 5 session.
Okay, okay. Amit, so you had the calendar, I mean, access of the calendar, right?
Yes, yes, yes.
Okay, if you click on the calendar, so there will be YouTube link for each session. Okay.
Okay, okay.
So you can find there, or you can find you can check the playlist of statistics 2 course. There
Yes.
we are adding each video after the session.
Okay, okay, sir.
Fine.
Thank you.
Okay, thank you.
Thanks.
Okay, then thanks all. Bye.
Thank you, sir.
Thank you. Thank you. Bye. Hope you got the some concepts. Okay. Yeah. Bye. Thanks you.